This video is going to talk about electrochemical cells. They're also known as voltaic cells or galvanic cells. The first step you're going to do when you get these problems is you're going to look for a reaction. If there's one, you could just jump to step 3. If not, you're going to have to figure out the reaction by using Table J in the New York State reference tables. What you have to know about Table J is oxidation is going to be above reduction on the table. It's really easy. Step 3, you're going to do you can determine which one's the cathode and the anode by using red cat and ox. Reduction occurs at the cathode. The anodes where oxidation occurs. One step about determining the electrodes, you have to pick the solid one. Electrodes can't be ions. What you're going to do next, step 4, electrons flow from lost to gained through the wire, or if you use Table J, just down Table J. Step 5, you're going to do the charge of the electrodes. You're going to notice the cathode's positive, the anode's negative. More importantly, you're just going to notice that the electrons flow towards the positive and away from the negative. And your size of the electrodes, you're going to notice that the cathodes get bigger and the anodes will get smaller. So, here's Table J. You have your list of all your metals, hydrogen's there as your standard. These elements up top lose electrons, these gain. These are oxidized, these are reduced, and if these are oxidized, they're really good reducing agents. Down here, since these are reduced, they're really good oxidizing agents. So hopefully you can remember that if you're ever asked. So what we have here, you've probably seen one of these. Zoom out a little bit. Here's your electrochemical cell. This is specifically a Daniell cell because of the copper and zinc electrodes. Now, which one's reduced? Which one's oxidized? I don't know. So let's look at our table. All you have to do is find copper, which is all the way on the bottom. Let me raise that up a little bit. Copper's down here. And zinc is right here. So since zinc's on top, this is oxidized. And since copper's on the bottom, that's reduced. So when I say zinc is oxidized, I have to remember that oxidation, the charge goes up. So there's two directions. You go from +2 to zinc 0, or zinc 0 to +2. It's oxidized, so it's going to go this direction. The zinc metal is going to turn to the zinc ion. Now in this half cell, you're going to get reduction, so the charge is going to go down, so the reaction's occurring in this direction. The copper 2 is going into copper. So you can actually write the half reactions underneath each half cell. So copper 2+ is forming copper, and we're going to put the 2 electrons on the left side because electrons go on the more positive side. The zinc is being oxidized to zinc 2+, and the 2 electrons go on the more positive side, which is the right side. So you just want to kind of keep track of everything. So this is oxidation, and this side's reduction. We can do our anodes and cathodes. Since this is reduction, this is the red cat, this is your cathode. Oxidation, anox, this is your anode. And this is the Zn metal. And the cathode is the copper metal. It can never be an ion. What we can do next is our electron flow. Now you have to think for a second. Electrons go from loss to gain, oxidation to reduction, or you just go down Table J, so from the zinc to the copper. So here's zinc, here's copper. The electrons are going to go through the wire, through the voltmeter to the other side. So you're going to have to do that on the regions. Just draw which way the electrons go. A part 2 question would just ask you which direction. In this case, you just say left. The charge of the electrodes. Now, since the electrons are going away from the zinc, they're being repelled. This is your negative electrode. This is your positive electrode. Over time, they're going to ask what's happening to the electrodes. Well, if you look at this half reaction right here, copper 2 is turning to solid copper, copper 0. This electrode's getting bigger. The anode, however, is dissolving. It's turning to ions, so it's going to actually get smaller. What else can we talk about? The salt bridge. The salt bridge in the middle is really important. You have an inert salt like NaCl, which is really Na plus and Cl minus. What this does, it keeps the whole system electronically neutral by allowing the ions to flow. That's pretty much my canned response for the regions. It allows the ions to flow. Because this creates a positive 2 charge, it's going to have to be neutralized by a negative charge, well, 2 negative charges. And because we're losing 2 positive charges here, 2 sodiums would replace each copper 2. And this is pretty much what a battery is, your voltaic or electrochemical cell. That's pretty much everything there. When this thing, when the battery dies, it's because you've reached equilibrium. The reaction's gone to completion, which means the copper ion has decreased enough and to form as much copper as possible, where the zinc has dissolved and formed Zn2+, and no more electrons are flowing. So it's neutralized, and the battery is therefore dead. So there's your electrochemical cell.